So we have this trig function. We're supposed to determine whether it's even or odd. Wait, sorry, no, that's the other video I just made. We're supposed to determine the period, the domain, the range, and we're supposed to draw the graph. So look, sine of x looks like this for a graph. And you could test this by plugging in sine of 0 in your calculator, you get out 0. And then sine of pi over 2. Sine of pi over 2 is 1. So the sinusoidal wave goes up to 1 as its maximum. And then it dips down by the time we get to pi, then it's back to 0. And then 3 pi over 2, it's down to negative 1. And then it's back to 0. Okay, so that's the graph. That's one wave of sine, and it just keeps repeating. Okay. So when they talk about the period, they're talking about how many x units it takes until you get back to this point, you start repeating itself. Sine of x has a period of 2 pi. Look, it took us, this is pi over 2, pi. I said this is 3 pi over 2, and you're at 4 pi over 2 here. You're at 2 pi before you start repeating itself. That's the base period of sine before you start messing with them. Now, if you multiply the x value by 2, that changes the period. So the period of a sine or cosine function is going to be 2 pi divided by b, and it's really the absolute value of b because our period we never listed as negative, but 2 pi divided by b, where b is this number. This is like the standard form of a trig function, a times sine of b, and it's really x plus, actually I think it's x minus c is what they do, but that's just the changing of a sign, and then plus d. Okay. Okay, so for this one, we're supposed to find the period. Does it say amplitude? I haven't talked about the amplitude yet, but the amplitude, if anyone ever talks about the amplitude of a sine function, that's how far it is from the midline, the line that cuts it in half horizontally, how many y units it is to the top. So this one has an amplitude of 1, but that's not part of this question. This question asks for the period. So the coefficient of x is what you need for b. So the period of this is pi. This sine function is going to repeat itself every pi units. The amplitude that I just talked about, we're going to need that to graph the function without a calculator. This is the amplitude. That's as easy as it is, the number multiplying out front. And the domain, look, it's a sine function. So as long as it's a sine function and it's not being square root or anything crazy like that, it's going to keep repeating this wave. The domain is all real numbers, negative infinity to positive infinity, because you keep this graph going, it's going to hit every x value eventually. Now the range, that one is affected by the amplitude that we're talking about. The one I just did here, the range is negative 1 to positive 1. But the range of this graph, it's being multiplied by 2, and what multiplying by 2 does is it bumps it up 1 unit. So we're peaking at positive 2, we're falling all the way down to negative 2, and then back up again. So the range, it's inclusive, it's negative 2 to positive 2. Okay, and then draw the graph. Okay, so, oops, I didn't want to delete that. I wanted to delete this. Oh, I'll just leave that. So we got all the parts answered. Now we're supposed to graph the function. You can use a graphing calculator to assist you, make sure you're doing it right. But it's just like other functions where you'd want a starting dot. Okay, the plus d part isn't a factor in our equation, so I don't have to do any vertical shift. That would move like this midline up 4 units or down 4 units depending on what d is, but there's no d in this equation. This helps us find the horizontal shift, okay? And so in order to do that, you've got to factor out the b like I wrote in here in the standard notation. So this is a sine, oh sorry, we're not doing a, we're writing out the actual numbers. So we got 2 sine, and then we factor out 2, then we got x, and it's got to be a minus. So we're going to say it's going to be minus a negative because it's the same thing as plus. And then we factored out a 2 from both terms. So if you factor out a 2 here, this should be pi over 6, right? Okay, so this part here, when you have it in standard form, c is negative pi over 6. And a negative actually, with horizontal shifts, actually means you go to the right pi over 6 units. And look, when I graph sine of x, I started my wave at the origin, right at the center, right? The horizontal shift of pi over 2 units to the right just means I'm starting my what am I looking for? I'm starting my graph here instead of at the origin. And then where do I want to end? I want to end pi units away because that's our period. So if I do, it's pi over 6, sorry, not pi over 2. That was our phase shift, right? So pi over 6 units to the right, and I'm doing a pi shift, so that means pi over 6 plus pi is 7 pi over 6 is where I want to end up. And that's when I should start repeating myself again. The amplitude is 2, so that means I want to mark out I'm going up to 2, down to negative 2. I need to do both of those before I come back to where the period's supposed to end. That's about as good as it's going to get. Okay, then that's the sine wave. But this emphasizes that we hit that peak of 2, the amplitude. We've done our pi over 6 unit shift to the right, and then we found out our period by using that b that I talked about. So I think that's it. For this class, it sounds like we haven't done this before, so use your graphing calculator, that's fine. Just wanted to show you how you can do that without a graphing calculator. That's usually done in pre-calc, is where you practice graphing that without a graphing calculator.